So this is June 2022. Question number one. Which equation represents the standard enthalpy change of formation for aluminium oxide? When 1 mole of a compound is formed from its elements in their standard states under standard condition, so aluminium oxide should be solid and it should be 1 mole. This is wrong. This is wrong. It may be A, it may be B. So the standard state for oxygen is O2, not oxygen. So A is correct. Question 2. How does an oxidizing agent change during a redox reaction? Oxidizing agent is the one which reduces itself. So reduces itself means it's going to gain electron. So oxidizing agent, I can say it gains electron. Oxidizing agent gains electron. So gains electron. We have two options A and B. We have two options A and B. So oxidation number. Let's say if something gains electron, let's say if I have Fe3 plus, when it gains electron, it changes into Fe2 plus. So this is called oxidation. Sorry, this is called reduction. So the charge decreases. So the charge decreases. So I can say option A is correct. In which oxidizing agent gains electron and the oxidation number is going to decrease. Which of these compounds would be expected to have the highest boiling temperature? Again, the same thing. I can say this is alcohol. This is alcohol. This is alkane. This is alkane. So this is completely wrong. It may be A, it may be B, then we have to see. Of course, option B is correct. You know why? Because in this option we have higher, higher surface area. When the surface area is higher, when the surface area is higher, so the IMF would be higher. What is the name of the compound with the formula KClO2? KClO2 means that if I find the oxidation number of chlorine in this one, so I know that potassium is +1, Cl we have to find out, and we have two oxygen, each oxygen is -2, is equal to 0. So Cl -4 plus 1 is equal to 0. So Cl is equal to -3 and then it's going to be +3. It should be B. Because in option B, oxidation state of chlorine is 3. Potassium chlorate 3. A small piece of calcium is added to a beaker of distilled water. What is the equation for this reaction? Small piece of calcium. Calcium is reactive metal. So distilled water, calcium would be reacting with water to produce hydroxide. Because they are saying, they are not saying that we are going to react with hot water. With hot water, it's gonna produce oxide, but with cold water, or we can say at room temperature, it would be producing hydroxide. So hydroxide, since the charge of calcium is 2, so that's why it should be D. It should be D because this is the charge of calcium. Which element is oxidized and which is reduced when calcium reacts with water? So if we can see this equation, I can say that the charge for calcium is 0 and the charge for calcium is +2 and the charge for hydrogen is +1 and the charge is 0. So calcium is losing electron, so means that this is oxidation. So calcium is oxidized. Element oxidized means calcium, calcium. We have calcium, calcium, we have two options, A and then B. So then element reduced, of course, element is hydrogen. So option B is correct. So option B is correct. Which is the ionic equation for the reaction of solid barium carbonate with dilute hydrochloric acid? So when barium carbonate reacts with barium carbonate, we have to see that this is going to be solid, is reacting with C. it would be producing barium chloride and carbon dioxide, and then we have water. This is gas, this is liquid, this is aqueous, this is aqueous, and this is solid. Okay, and this is solid. So in order to write an ionic equation, we are not supposed to break down the solid one. So barium carbonate will remain same. I will be dissociating H plus and Cl minus, and then barium 2 plus 2Cl minus, carbon dioxide as it is and water as it is. Cl cancels each other. So as a result, I would say that option A is correct. Option A is correct, right? So question 7, the presence of ammonium ion in a compound can be shown by adding a reagent, warming the mixture, and testing the gas evolve. What is the reagent and the result of the test of the gas evolve? So ammonium ions in a compound, we know that ammonium ion releases ammonia. Ammonium ions releases ammonia after the addition of a strong base, that is sodium hydroxide. Sodium hydroxide is a strong base. So there would be displacement reaction because a strong base would be substituting the weak base, and weak base is ammonia. So NaOH, NaOH, we have two options, C or D. So ammonia gas is released. We know that ammonia is a basic gas. So it will change red litmus into blue. So means that option D is correct because in which red color is going to blue. B for base and then B for blue. Aqueous chlorine is added to
Sir, how do we know which is a strong base or a weak base?
group 1 hydroxides are strong bases, others are weak bases. And ammonia is weak base. We know ammonia is a weak base. Aqueous chlorine is added to an aqueous solution of potassium iodide. Means that chlorine is going to react with potassium iodide solution. A non-polar organic solvent is then added and the mixture is shaken. The layers are allowed to separate. What color is seen in the organic layer? So, like, of course, in the reactant, we have chlorine and potassium iodide. Since chlorine is more reactive, so there would be displacement reaction between iodide and chlorine. So I would see iodine, and the color for iodine would be violet color. A titration is carried out by adding dilute sulfuric acid from a burette to aqueous sodium hydroxide in a conical flask. The indicator is methyl orange. What is the color change of the indicator at the end point of this titration? Since we know that methyl orange is red in acid and it's yellow in base. And it's yellow in base. So in a conical flask, I have sodium hydroxide. So when you will be adding methyl orange to the conical flask, so I would see uh, yellow color. Okay. So it would be yellow 2. So we have two options, yellow 2, yellow 2. It may be C, it may be D. So it's yellow to, so it's yellow to orange. A student carried out the first titration and did not notice that there was an air bubble between the tap and the tip of the burette. Okay. During the titration, the air bubble filled with acid. The student then carried out two accurate titrations in which there was no air bubble in the burette. There were no other errors in this titration. Which of these could be the three titers for this student? Yes. Air bubble. Air bubble is going to make your calculation inaccurate because you will think that the burette is filled but in actual it's not filled. There is air bubble. It's going to occupy the volume. So in reality, the volume of liquid is lower. The volume of liquid is lower. So during the titration, the air bubble filled with acid. When you are doing titration, so of course the air bubble would be filled because you are going to open the tap and the acid would be coming from the burette to the conical flask. So at that time, the air bubble filled with an acid. The student then carried out two accurate titrations in which there was no air bubble in the burette. There were no other errors in these titrations. Which of these could be the three titers? Remember, so initially we are supposed to have higher volume. Initially, we are supposed to have higher volume. So it may be C, it may be D, because this is understood that the volume will not remain the same. Of course, the volume is going to decrease. So we may have C and it may be D. So then, what can I say? It may be C or D. What do you think? Maybe C or D. Hmm?
C.
Exactly. C is correct. What is the concentration in mole per dm cube of the sulfuric acid? So mole of sodium hydroxide is equal to concentration, that is 0.1 multiplied by the volume in centimeter cube divided by 1000. It would be giving you the moles of sodium hydroxide. Then you have to take the mole ratio between sodium hydroxide and sulfuric acid. That is going to be 2 is to 1. Okay, that is going to be 2 is to 1. So 25 divided by 1000 multiplied by 0.1 is equal to 0.0025. 0.0025 mole. So this is 0.0025 mole and this is X. This is X. So X would be equal to 0.00125 mole of H2SO4. They are asking the concentration. Concentration is equal to mole upon volume. Mole is 0.00125 divided by the volume. It should be in decimeter cube. So divided by 1000 is 0.0187. 0.00125 divided by 0.0187, it would be equal to zero point zero 0.06. So the answer is B. Hydrogen peroxide decomposes as shown. A catalyst increases the rate of decomposition by catalyst. What the catalyst does, it decreases the activation energy, it provides alternative pathway, and uh, without it's being used. So decreases the activation energy of the reaction. So means D is correct. Bottle of hydrogen peroxide is labeled as 10 volume. This means that 1 cm cube of hydrogen peroxide solution decomposes to produce 10 cm cube of oxygen at room temperature. What is the concentration of 10 volume hydrogen peroxide in mole per decimeter cube? Molar volume of gas is 24,000 centimeter cube. So it means that 1 centimeter cube of H2O2 decomposes to produce 10 cm cube of oxygen. 10 cm cube of oxygen, right? They're asking the concentration of hydrogen peroxide. So what do you think? What should be the answer? This is good question. Mhm. Keeping in mind 1 cm cube of H2O2 gives 10 cm cube of oxygen, 10 cm cube of O2.
Sir, the moles of oxygen would be equal to the moles of hydrogen peroxide because it's at the
No,
room
the mole
temperature.
ratio is 2:1.
Oh, okay.
Then, should I tell you?
I'm doing this.
Mhm. Mhm.
Is the answer D?
D for doctor,
D?
yes.
Yeah.
Good. So, first of all, what you did, you found the number of moles of oxygen that is equal to 10 upon 24,000. 10 upon 24,000. So you got the number of moles of oxygen that is 0. Uh, I can say 0.00 and then 416, right? Mole of oxygen. Since we know that oxygen and H2O2, so the mole ratio is 1:2. I have the moles of oxygen that is 0.000416. It would be X. So X is equal to 2 multiplied by this would be giving you 0.0042 the 8 and then 4 2 4 the 8 2 1 the 2 around this one. Mole of H2O2. Mole of H2O2. Okay. This is the mole of H2O2 in this volume. If I convert this cm cube into dm cube, so 0.001 dm cube of A2 have this much moles. So if I have this much volume, because they were asking in mole per decimeter cube, this is gonna be X. So that's my answer D is correct. So that's my answer D is correct. Okay. And a mixture of hydrogen and iodine is left in a sealed container at 300 degrees Celsius until equilibrium is established. The equilibrium mixture is then cooled and the color of the mixture darkens. Which is correct. Darkens means that iodine is brown in the reactant side and HI is a gas, it's a colorless. So it's understood that the position of equilibrium would be left because we have an iodine. That's why the color becomes darker. Left, 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 we have two options, A and B. We have two options, A and B. Enthalpy change of forward reaction. In a forward reaction, bond is being formed between hydrogen and iodine. When the bond is being formed, so the reaction should be, so the reaction should be, no, yes, what they are saying, a mixture of hydrogen and iodine is left in a sealed container at 300 degrees Celsius until equilibrium is established. 300 degrees Celsius, 300 degrees Celsius means at a higher temperature, it's going to form a product. So, what do you mean by this? The reaction should be endothermic. The reaction should be endothermic. That's the reason. That's the reason at a higher temperature, the reaction is going forward. Okay. What type of reagent will attack the partial positive carbon? Positive. Positive means nucleophile can attack on positive side. Yes, C is correct. Good. Which of these alcohols will produce a carboxylic acid when heated under reflux with acidified potassium dichromate? It should be primary alcohol. So this is 1 degree. This is also 1 degree. This is 2 degree, and this is going to be 3 degree, right? So which of these alcohols? P and Q. Yes. So B is correct. Two reactions of cyclohexanol are shown. What is the reagent for reaction 1? Shown for reaction 1 means that it's gonna be 2 degree 2 degree alcohol. So 2 degree alcohol means that it's converting into the double bond. It's converting into the double bond. So alcohol to alkene, right? Alcohol to alkene. So means this is dehydration reaction. And for the dehydration, we need dehydrating agent. Remember, I told you the dehydrating agent, it's supposed to be concentrated phosphoric acid, it's supposed to be concentrated sulfuric acid, and it's supposed to be aluminium oxide like Al2O3. Okay. So answer is C. So answer is C. The reagent for reaction 2 is acidified potassium dichromate. In reaction 2, alcohol is being oxidized into a ketone. So which equation best represents this equation? So first of all, I have to find out the formula for this. It's C6H, then H, 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 then H. And this is the H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C6H12O, or I can say C6H11OH. C6H11OH. So it may be A.
Okay.
Oh, all the options are correct. Okay, C6H11OH. You're saying C.
Yeah, because it's being oxidized, so no need to check.
Yes, good. Because the symbol for oxidizing agent is partial, like atomic oxygen. Atomic oxygen is very reactive, that's why. And reducing agent is represented by the same thing, but with H. Atomic hydrogen. Okay. A cyclohexanol and cyclohexene each has a peak in their infrared spectrum which is not present for the other compound. What are these peaks? Cyclohexanol means we are supposed to have OH group, and cyclohexene means we have alkene group, right? Each has a peak in their infrared spectrum which is not present for other compound. So uh, you will see the data booklet, you will see the values. Peak only in hexanol. Only in hexanol means that we are supposed to have OH, and peak only in hexene. It's supposed to be for the alkene. I don't remember the values, but I remember the value for the alcohol. It was C, like 3500, like around 3500. So it may be C and it may be D. It may be C and it may be D. So I don't remember another value. I can say it may be C, it may be D because this is the value for the OH. This is the value for the OH, and for the alkene like carbon carbon double bond, let me check the values from the booklet. Okay. Okay. Yes. Hmm. Okay, the value for alkene is in between 1669 to 16. So the answer is C. So you're not supposed to memorize this, by the way. You will see. And okay. Mhm. Okay. So this question is about calcium carbonate. Calcium carbonate decomposes on heating. Explain why calcium carbonate decomposes at a higher temperature than magnesium carbonate in terms of the charge and the size of the cation. Okay. So, so, so calcium is greater than magnesium, but the charge is same, that is plus 2 and plus 2. Since the size of calcium is greater, it cannot polarize. It cannot polarize carbon and oxygen bond. So means that higher temperature is required to polarize the carbon and oxygen bond. And we know that the size of magnesium is lower and it would be having a stronger attraction, so it can polarize the carbon oxygen bond easily. So in other words, I can say it can distort the carbonate ion into carbon dioxide. So what am I supposed to write? It's of 3 marks. It's of 3 marks. So I would say that um, calcium 2 plus has larger ionic radius, larger ionic radius compared to magnesium 2 plus. Okay. Or so calcium 2 plus, so calcium 2 plus has less polarization power to distort carbonate ions. Calcium carbonate reacts with this. The gas syringe is this. Okay, 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 okay. Calculate the volume. Okay, okay, okay. Calculate the volume of HCl that can be added to excess calcium carbonate at room temperature. Or okay, okay, okay. So, only the concentration of HCl is given to you. And for the concentration and for the volume, we need to have the mole of HCl. When we would be having the moles of HCl, we have the concentration of HCl. We can write down the formula N is equal to Cv to find out the volume for the HCl. So for this one, we need to have the number of moles of HCl. How can we find out the number of moles of HCl? What he is saying, the gas syringe can measure a maximum volume of 100 centimeter cube of a gas. So this is the volume of carbon dioxide. Of carbon dioxide. So the mole of carbon dioxide would be equal to the volume, that is 100 centimeter cube divided by 24,000. It would be giving you the mole of CO2. When you have the mole of carbon dioxide, since the ratio between HCl and carbon dioxide is 1 is to 2, okay, like 2 is to 1, I can say. So 100 upon 24,000 would be giving you 100 upon 24,000 would be giving you 4.166 exponent minus 3 mole of CO2. So if this is the mole of CO2, that is 4.166 multiplied by 10 raised to the power minus 3, this would be x. This would be x. So x would be equal to this value multiplied by 2, that would be 8.33 multiplied by 10 raised to the power minus 3 mole of HCl. I have to find out the volume of HCl. So the volume would be equal, mole is this one, and the concentration is 0.5. So the answer would be 0.5. Okay, 0.5 mole per decimeter cube. Yep, mole per decimeter cube. And what they're asking, maximum volume that can be added to excess calcium carbonate. Yes. So what's the answer for this? 8.33 exponent minus 3.
0.016.
0.16. Yes. And also we can do 16 point something decimeter cube, centimeter cube. The results of the student's experiment are shown on the graph. Calculate the initial rate of this initial rate. In the last paper we were doing this question and the answer was wrong. I was telling you that when the examiner would be asking the initial rate, then we have to do the thing that we did in the last question. Calculate the initial rate of this reaction. You must show you're working on the graph. Include units in your answer. So, so for the initial rate of reaction, calculate the initial rate of this reaction. Yes. So this question is of 3 marks. Okay. So for initial rate, I am supposed to draw the line through this point. So, the value at, I'm sharing my screen. The value would be y-axis and the value would be on x-axis. So we can calculate the rate y upon x, volume per unit time. So this would be your that is going to be 100 and this is going to be your time that is going to be 360. So the answer would be rate is equal to volume upon time. Volume upon time. So the volume was 100 and the time is 360. And the time is 360. So the answer would be 0.278. Volume is in cm cube and the time is in second. So centimeter cube per second. That's the answer. The student repeats the experiment but uses hydrochloric acid with a concentration of 0.250 mole per decimeter cube. All other variables are kept the same. State what would happen to the initial rate of the reaction and the final volume of carbon dioxide collected. Initial rate of the reaction. They are going to repeat your reaction, Initially, what was the concentration? Initially, what was the concentration? That was 0.5. And now what they are saying? 0.25. So the concentration decreases. When the concentration decreases, so the rate decreases. When the concentration decreases, so the rate decreases, right? When the concentration decreases, so the rate decreases. So exactly the concentration becomes half. Exactly the concentration becomes half. When the concentration becomes half, so the rate will be halved. So I can take an idea if this is going to be 90. This is going to be 90. So the half of 90. So the half of 90 would be 45, isn't it? And 45 would be around, I can say this is going to be 50, 41, 42, 43, 44, 45. No, 42, 44, 46, 48, and then 50. So it may be 44 and like that. This is the half, right? So I can say, okay, so final volume of carbon dioxide collected would be decreases by half.
Sir, I don't understand.
Sorry?
I don't get it.
Okay.
Can you explain it?
They are saying the student repeats the experiment but uses hydrochloric acid with this concentration. So when we were doing this experiment, the concentration was 0.5. You can see in the last question. You can see this statement when we have calculated the concentration. Oh, and they have given the concentration that is 0.5 of hydrochloric acid. But they are saying someone is going to repeat the experiment with this concentration. It means that the concentration is half. Half of 0.5 is 0.25. It's exactly half. Half of zero point 0.5 is 0.25. When the concentration becomes half, so what's the relation between the concentration and the rate of reaction? You will see directly proportional. When the concentration increases, so the rate increases. When the concentration decreases, so the rate decreases. When the concentration increases by 10, so the rate increases by 10. When the concentration decreases by 10, so the rate decreases by 10. Okay. So it's all about the change in concentration. So that's why I took an idea. If the concentration becomes half, so I have to see the curve, like this curve is at this volume. Remember, this curve is at this volume when the concentration is zero point 0.5. What if the concentration would be 0.25? So I have just half the volume, isn't it? It should be 45. Okay.
Sir,
It's
why not 50?
why not half of 90? Half of 90. It's 90. Half of 90. Half of 90 is 50.
No, no, no. I thought you're supposed to take
Yes.
100. Okay.
So 40, like 45. So that's why I made a line like that. Simple.
Okay.
Or I can say, yeah, okay. So that's the volume. This question is about the halogen and some of their compounds descending the group from fluorine to iodine. The electronegativity of the atom decreases even though their nuclear charge increases. Explain the trend in electronegativity is an ability of an atom to attract electrons towards itself, but in a covalent bond. But in a covalent bond, remember. So I can say why the electronegativity decreases, ability to attract electron decreases. It's all about the atomic radius. It's all about the atomic radius. And why the atomic radius increases? Because, the number of shells are increasing. Number of shell means the distance between the nucleus and outer electron. When the number of shell increases, so the distance increases. Why? Because due to the more number of shells. So when the size is larger, so atom cannot attract electrons towards itself. So I can say the electronegativity should be, so I can say that the electronegativity should be lower. It's of 2 marks, so I'm supposed to write that. Um atomic radius increases from fluorine to iodine, from fluorine to iodine, due to more number of shells, due to more number of shells. Okay. So more number of shell means that the distance between electron and nucleus would be higher. So if the distance is higher, so there would be weak force of attraction. There would be weak force of attraction for the bonding electrons. Like I want to say this one. This is, it would be just like that. Partial negative, partial positive. You know it's why? Because it's more electronegative. More electronegative.
Or can we just
This
say
is
that
less
shielding
electronegative.
increases?
Yes. What increases?
Shielding effect. Can we just say that?
Shielding effect.
Yeah. Or just shielding increases?
Yeah, you can say shielding because when number of shell increases, so of course inner electron increases due to the increase in number of shells. When inner shell increases, so it's mean that the shielding effect would be like increasing. Okay. So, and if you can see this one, explain in terms of oxidation numbers of iodine and the three specific species why this is not a disproportionation, why this is not a disproportionation reaction. So why this is not a disproportionation reaction? Because for a disproportionation reaction, the same substance should be oxidized. The same substance should be oxidized or reduced, right? So for this one, uh, the charge for I is supposed to be, I can say IO3 minus. For this one, I plus 3, oxygen is minus 2 is equal to minus 1. Okay. I minus 6 is equal to minus 1 is equal to minus 1. So minus 1 and then minus 6 and then plus 6. So minus 1 plus 6 would be equal to plus 5. So the charge for iodine is plus 5. And the second iodine is minus 1. It's changing from plus 5 to 0 and minus 1 to 0. Okay. Uh, plus 6 to 0 and then minus 1 to 0. Plus 6 to 0 means that the charge is decreasing, isn't it? Plus 6 to 0 means the charge is decreasing and minus 1 to 0 means the charge is increasing. So why this is not a disproportionation reaction? Because the condition for a disproportionation reaction is that the same substance is being oxidized and reduced. So so this is plus 5. Oh, yes, this is plus 5 and this is going to be minus 1 and this is 0, right? This is 0. So remember, only one product is formed. Let me tell you the previous reaction in which I was reacting chlorine with water. So, in that reaction, we had two products, HCl and HClO. HCl and HClO. Like we had two products. In HCl, the oxidation number of chlorine was -1, and in HOCl, the oxidation number of chlorine is +1, right? So, like for a disproportionation reaction, we are supposed to have two products. But in this reaction, we have only one product is formed. So we can also write this one on the basis of charge. So only one species is formed. Okay. See this one? Hydrogen bromide and hydrogen iodide reduce sulfuric acid. Identify by name or formula the compound produced containing sulfur with its lowest oxidation number in that reaction. Again, for this reaction, you are supposed to memorize the reaction. How much products are formed when the sulfuric acid is reacting with HBr and when the sulfuric acid is reacting with HI. Do you remember the reaction with
Yeah,
HBr? With HBr, this is a weak reducing agent. This is weaker reducing agent.
we get SO2. That's the only sulfur containing product we're getting.
This is a stronger reduced. Mhm. So this is going to be sulfur dioxide with the lowest oxidation number, and this is going to be H2S in which the sulfur is -2. This is +4. The thing is that why it's producing the lowest charge with iodide, because iodide is the strongest reducing agent. So it reduces sulfuric acid into this one. It's stronger, so that's why you are getting the least number. And if this is not stronger, if this is weaker, so you are not getting the least number. It's as compared to -2 +4 is greater, of course. It's all about the strength of the reducing agent. Explain the trend in the boiling temperatures of hydrogen halides. From hydrogen halide, since you know that HF is at the top because it's going to have hydrogen bonding, and then you have HCl, HBr, and HI. First decreases and then increases. Why the first was higher? Due to hydrogen bonding. Otherwise, it should be like that. Like expectedly, it should be over there, but it's here. Why? Due to the presence of hydrogen bonding. And except this one, let's say I'm going to discuss these three. So as the number of electron increases, so the London force increases. And due to the increase in London force, so I can say that the melting and boiling point increases. So it's of 4 marks. Okay. So, all the four halides that you can see will be having London force. I told you that London force is present everywhere, like, but HF and all are polar as well, polar, 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 all have permanent dipole as well. But HF is going to have hydrogen bonding. So the strength of hydrogen bonding is higher. So that's why this molecule is more polar. It's have stronger IMF. That's the reason it's going to have highest melting and boiling temperature. And then if we can see HCl, HBr, and HI, then for these three, we can say the number of electron increases. Due to the increase in number of electrons, so the dipole-dipole attraction becomes more stronger. So let me tell you first that due to hydrogen bonding, due to hydrogen bonding, it's at the top. And if you can see HCl, HBr, NHI, so it's like that. No, no. It's like that. So it's due to the number of electrons. When the number of electron increases, so the London force increases, boiling point increases, right?
Sir, they all are polar, right? So they'll
Or
have
are they all
permanent
are polar?
hyperlisis.
Yes, they all are polar. Yes, all are polar, and all contains temporary, all contains temporary and permanent dipole. But the strength of dipole is different, of course. It depends on the number of electrons. A sample of seawater was evaporated to dryness. The solid residue was weighed, then dissolved completely in deionized water. Excess aqueous silver nitrate was added to the solution. All the chloride ions in the seawater formed a precipitate of silver. Okay. Calculate the percentage of chloride ion in a solid. Percentage means that the thing that you are going to find out should be in the numerator. The total should be in the denominator and then multiplied by 100. So first of all, we have to find out the mass of chloride so that I can find out the percentage of chloride. So to get the percentage, we need the mass. So for the mass, they have given you some information, mass of solid residue from seawater, then mass of silver chloride precipitate. So how can we find out the mole first? Mole of would be equal to this is the mass of AgCl, the precipitate of